Welcome to Engineering Drop. Today we are going to dive into visualization of motion in terms of velocity and acceleration. Let's start. A particle is moving along a curved path which lies in a single plane. Here you need to understand two things: the path of your particle, which is curved, and that the motion is just in a single plane. That means the motion is dimensional only. Now let's consider the motion as it moves through the curve from point A to point R prime. Now when your particle is moving on this path from bottom to top, we are observing the particle at the points A and A prime. Point A is located at displacement or position vector r from the point of observer OO, and A prime is located at r plus delta r from the point of observer OO, when delta r is position vector of A prime from the point of A. Now, what is the direction of velocities of a particle at A and A prime? Interesting, we need to draw a tangent line to the curve at each point to get the direction. The forward tangent line to the path at A will be the direction of the velocity at A. In similar way, the forward tangent line at A prime is the direction of the velocity at A prime. And another thing we need to know is that the length of the velocity vectors represent their magnitude. But how to know the direction of the accelerations at these points? To know this, first we need to know what acceleration is. As you know, acceleration is the rate of change of velocity. Now, the change in velocity involves both change in magnitude and direction. Therefore, the direction seen in change in velocity will be the direction for the acceleration. In vector analysis, initial velocity v plus change in velocity gives final velocity v prime. Here, you see that the direction of velocities tend to the outside of the curvature path, while the direction of the acceleration tends to the inside of the curvature. Alternatively, you can visualize the direction of acceleration using a curve called hodograph. Let's see how the hodograph curve is formed. Consider 3 points which are under observation from point O. The tail of the 3 velocities drawn at the 3 points are now dragged to some arbitrary point C. Then the head of each velocities are connected with a curve. The curve is called hodograph. Now, if you draw a tangent line to the curve at each point, you will find the direction of acceleration at each point. Now let's describe the same thing using rectangular coordinates. From the point of observer, point of the particle is described with position vector r. It can be described as x with unit vector I and y with unit vector j, and as we said earlier, velocity at a point is tangent to the path of the particle. And you can decompose this inclined velocity to x and y components, as you can observe from the figure. The direction for acceleration, which is decomposed here, is as we discussed earlier. It is in the direction of change in velocity. Let me show you again. Consider the velocity at any point below the given point. Then the direction of change in velocity is as you see. You can do the same thing for any point velocity above the given point. The direction of change in velocity in this case is also almost similar. It tends to the inside of the curve by any means. I hope you can now visualize motion of a particle along curve in terms of velocity and acceleration. Thank you for watching the video, and do not forget to subscribe the channel.